All right, then let's get started. So welcome to this Cirrus Link webinar to see new advanced features providing innovative solutions with MQTT and Ignition 8. Today, we're excited to present to you new features in our Ignition 8 MQTT modules, which will enable you to create powerful, new, and innovative solutions. While we'll be using an oil and gas project as our use case study, these features can be applied across any industry vertical. My name is Chris Houghton, and I'll be serving as the moderator today. With me is Arlen Nipper, President and CTO of Cirrus Link and co-inventor of MQTT, the lightweight publish-subscribe messaging protocol. With us is Ben Orchard, Senior Application Engineer at Opto22, to help show us some of the powerful capabilities of their Groov Epic and Groov Rio products. We also have Kyle Muldoon, SCADA Development Project Manager from Avadine, who will show us their data visualization and analytics tools within Ignition. So as you can see, we're literally going from plant floor up through OT to data visualization in IT with the lightning fast and efficient MQTT technology. First, a little background about Cirrus Link Solutions. Founded in 2012 by Arlen and myself, we have over 80 man-years of experience in-house implementing solutions using MQTT. Our MQTT modules enable the Ignition platform to connect OT data to IT services for big data analytics, while providing a superior OT solution. Cirrus Link developed the Sparkplug-B specification, which has been open sourced through the Eclipse Foundation and is rapidly becoming the de facto standard for open interoperability within the industrial market for hardware and software manufacturers. We are one of only 2 strategic partners to Inductive Automation who created the Ignition platform for SCADA and MES. We have extensive experience in designing and implementing MQTT solutions. So we've seen a lot of challenges and concerns that people typically have about using this technology and solved them previously on other projects. In this hour, we'll start with a review of the MQTT specification and Sparkplug-B, showing how this ties back to our Cirrus Link MQTT modules in Ignition 8. We will then review some of the exciting new features we have with our modules in Ignition 8 and how these will be part of the demo today. Next, we'll have Ben take us through some of the capabilities of their hardware platform, showing how easily they can be configured to send your OT data to any data consumer throughout the enterprise. Lastly, we'll have a live demo showing the end-to-end solution, with Kyle showing us their data visualization tools in Ignition. This will be followed by a Q&A session. So if you have any questions, feel free to post them in the chat window as we go through the presentation. So without further delay, I'd like to hand over to Arlen Nipper to get us started. Arlen, over to you.
Thanks, Chris. Appreciate it. So before I actually jump into it, I'm going to go back to our modules page here. One of the things I want to mention is that when Chris and I started Cirrus Link, we really, we wanted to provide MQTT-centric software. The exciting thing to me is, like Chris said, Andy Stanford Clark and I kind of on a project for Phillips 66 in 1999. There was no Internet of Things. There were no cloud service providers. People were just learning about TCPIP in the industrial space. So we needed a platform to be able to take the vision that we had with what we could do with MQTT. And the very first module that we created was the MQTT engine module. We had one module. We presented that at the Inductive Automation Conference 4 years ago, almost 5 years ago now. And it's kind of taken off from there. So one of the advantages that we have here is that we're leveraging the capabilities of a platform. So we can design modules with capabilities and plug that in and then leverage the tools that Inductive Automation give us with the Ignition platform. So our mantra has been from day one is that in 2020, we need to forget about protocols. We need to forget about poll response protocols because those actually make us connect a device to an application. Now, on day one, that's not bad, but day two, week two, year two, when other people want additional information from that device, it's hard to break into that one-to-one relationship between a poll response protocol and the device. So what we're saying is that wherever possible, we should decouple. We should be thinking about connecting devices to infrastructure, not to applications. The second thing is that we want to have a notion of providing a single source of truth as far out at the edge as we can. Because if you think about what we've been doing for the last 40 years in operational technology, is that we were dealing with register value pairs. So we had a Modbus register, 40,002, and it had a value of 10, let's say. Well, is that 10 degrees? Is that 10 gallons? Is it scaled? We don't know. So what do? We have to double click on that tag and give it context. So we double click on that Modbus register and we say, well, this is Modbus register 40,002, but we're going to call it pressure. And that value is 0 to 125 somethings. And those somethings are going to be PSI. And oh, by the way, this is going to be a floating point data type. So we hope we get that right. But as you look at this, as we scale out into IIoT, digital transformation, industry 4.0, whatever you want to call it, now we may have multiple consumers of that piece of data. So how many times do we have to edit that? Are there 5 consumers? That means that every time we add another point, that's 5 times we have to edit that tag. So what we're saying is that we should provide the technology to move that single source of truth as far back as we can. And then everybody that's consuming the data going forward has that source of truth for those tags, those models, and those assets. And then lastly, step 3 is that we always realize is that although we're talking about OT, IT integration, we're talking about cloud computing, at the root of all of this, we still need to be able to demonstrate a better, faster, more secure, more scalable, more available operational solution first and foremost. We can't forget that going forward. So if we look at how we've been doing SCADA, it's not bad. In other words, we have a SCADA host system, we have some PLCs, RTUs, factory equipment out there in the field. We take a network and we start poll response. We bring that into our dashboards. We have our alarming, we have our reporting. Life is great. But then, as we migrate towards digital transformation, we have other needs. So I need information that currently operations wasn't polling for. So I have to go to the operations manager and say, can you please poll for information that you're not interested in, but I need access to it so that I can pipe it through and take it to my application that the business needs. And the operation manager, he's a good guy. He says, okay, we'll add that additional poll. And then somebody else found out and said, well, if you did that, I want this other information. Well, okay, we're going to add that. And then as this scales out, we get to the point where in a lot of the applications that we've seen is the system gets so customized, so brittle that everybody goes, stop. We don't know how all this fits together. We've had to add firewalls. We have custom applications. We have code running out there. We can't scale anymore or the system's going to break. So how do we get around this issue in scaling forward? And if you look at it and you understand MQTT as a message-oriented middleware, what we're doing is we're trying to make SCADA hosts, applications like that, we're trying to make them look like message-oriented middleware, which they were never intended to do in the first place. So keeping the current equipment, keeping everything in place, how can we scale moving forward? So if we look at this from a point of, we have our brownfield equipment, we have our operational data out in the field, what if we could provide edge technology that would let us decouple? So we can connect to those devices over any TCPIP network and then be able to take that information and decouple by publishing it to an MQTT server. Okay, so now we've accomplished the decoupling, and then with MQTT and Sparkplug, we've got this capability of providing a single source of truth. Now, from an operational standpoint, we can plug the Ignition platform in with MQTT engine, connecting to that MQTT infrastructure, and discovering all of the information from an operational standpoint that we're interested in. Now, at this point, what's very unique is that I can plug another Ignition system in, or anybody that's MQTT capable, and they can subscribe to that information as well. So we have customers that plug this in and they use that as their development system. So they can actually develop with live information, watching that information. Now, as we scale forward, we can start taking that data that used to be stranded and take it to other applications, cloud services, and anybody else that wants to plug into this decoupled architecture. Now, what does the anatomy of an MQTT infrastructure look like? So we have to have an MQTT server, and in many cases, we can have multiple MQTT servers for high availability and redundancy. And then we have clients. So in this case, we'll have an edge client, and this could be running on Ignition Edge, and it's connected to devices that we have out in the field. Now, again, we fully realize that poll response protocols aren't going to go away in the next decade, at least. So we're able to pull that local equipment and bring their process variables into that Ignition Edge. And now we're able to make a connection to an MQTT server. Now, note right now that this is an outbound connection to an MQTT server. So from a security standpoint, leveraging TLS, we have a very secure architecture because there doesn't need to be any ports open at the edge. Now, once we've connected, we can subscribe to information that we're interested in, and we can publish the process variables coming in from the edge devices. Now, notice we're completely decoupled. We don't care who consumes that information. Now, on the other side, we can have another MQTT client, a host client, and this could be running on an Ignition gateway, and it can connect and subscribe. And once it does that, it's getting all of those real-time process variables on a report by exception basis. So one of the huge advantages of MQTT is that we've shown over the last 20 years that if we replace a poll response system with a MQTT infrastructure for the same tags at the same update rate, we get an 80 to 95% bandwidth reduction. Now, in 1999, when Andy and I did this, that meant an 80 to 95% reduction in their communications costs. But in 2020, I think that means that that is 80 to 90% more stranded information that we can bring in over the same bandwidth. Now, realize at this point, we're bidirectional in that once we have our MQTT session established, we can send commands over that channel. So that gives us the command and the command capability for bidirectional communication once we have our MQTT infrastructure established. Now, we can start adding, now the advantage is now we can add other consumers of that information. So they can subscribe, and now we have a one-to-many architecture that is very easy to accomplish. So we can add other clients, native devices that implement MQTT and Sparkplug, and what we end up with is a one-to-many, very secure operational system that can scale to cloud services. Now, the three core modules that implement MQTT are here. So we've got MQTT Transmission. So what is that? That is a module that plugs into the Ignition platform that understands how the tag structure is implemented in Ignition. So it can see all of the tags that you have in the Ignition system. Then it can grab those tags, convert those to MQTT messages, and publish those. Now, the next module is MQTT Distributor, and that is a proper 3.1.1 compliant MQTT server that is actually a Ignition module. So it's very easy to add an MQTT broker or server, if you will, to your infrastructure. And then finally, we've got MQTT Engine. It is the reciprocal of transmission in that it can subscribe to information coming over our MQTT infrastructure. Then it can convert those to tags and folder structure inside of Ignition. So that's where we get our auto discovery plug and play capabilities with MQTT Engine. Now, if we look at this in an infrastructure standpoint, we've got our edge devices out here. We're using all of the protocols that are already built into Ignition, being able to pull those tags into our tag provider. MQTT Engine takes those tags and discovers the architecture, the folder structure that you've got in Ignition, publish those as MQTT messages to an MQTT server. In this case, this is MQTT distributor. Then Engine can connect to distributor, and it can auto discover the tag structure out here that's being provided and put that into an Ignition infrastructure. Now, we've talked about MQTT and all of the advantages. And again, this is kind of a refresher in just the basics of why MQTT has become such a dominant message transport. And number one, it's extremely bandwidth efficient. It's stateful. In other words, we know the state of those devices that are providing us with information, because in a real-time command and control situation, we don't want to have devices that we want to send commands to and not know their state. And it decouples, so we can have, as I showed, we can have a one-to-many relationship with our information. And since we built MQTT on top of TCPIP, we let TCPIP do a lot of the heavy lifting. You know, it does the packet reassembly, it does the CRC checking, and we get to leverage the latest security technology as it applies to the TCPIP transport and not any one particular protocol. Now, the wonderful thing about MQTT is you can publish anything you want on any topic. But as we start to scale, as we start to want auto discovery, the bad thing about MQTT is that you can publish anything you want on any topic. So when we started looking at the landscape here 4 years ago, we started seeing a lot of talk about MQTT. We had OEMs that were implementing it, and as everybody knows, we had Microsoft Azure, we had AWS IoT, we had Google Cloud Platform, we had IBM Watson IoT, and everybody were doing MQTT, but everybody were doing it differently. So 3.5 years ago or so, we decided to sit down and take all of the legacy knowledge that we had in implementing operational networks with MQTT and put that in a spec called Sparkplug. And very simply, Sparkplug defined a common topic namespace that made sense. It defined a payload that was very efficient, and it defined how best to use the state management. So the way that I look at this is that the Internet of People literally scaled exponentially because there were two open source technologies that were available. HTTP was the messaging transport, and HTML defined what was in that transport. And for us to scale, like the visionaries have said, we need the same notion at the operational level. So we have MQTT as our transport, and then we have the Sparkplug specification that defines what's in that transport. And if we do that, we're getting to the point where we get a single source of truth for all of our OT information. Now, very quickly, expanding out a bit, is that what does a well-defined topic namespace do for us? Well, it gives us plug and play auto discovery. With this notion of a group node device ID, we know where these messages came from. With the birth message, we know, oh, there's a new device out there. We can discover that device, and we can know what information it wants to provide to us. With the data topic, we're able to do report by exception. So once we publish our berth with all of our process variables, if a pressure is 100, then we don't need to publish it again until it changes. So when it changes to 101, we can publish that on report by exception. With the command topic, we're able to do a bidirectional command and control. And of course, if we have a berth, we have a death that tells us that that device is no longer available, and we should do something appropriate with the information. In the case of ignition, we should set the tag stale. Now, very importantly, Sparkplug also lets us define a model from the edge. So we've got this notion of a template definition, which allows a berth message to define a model. And then instances of that or instantiations of that become assets, and those assets have process variables. And we have the notion of a efficient binary encoding of a process variable object, so that now we know that that's a pressure, we know its value, its timestamp in milliseconds, its data types, and now with Ignition 8, we can add custom properties to that. And then finally, proper state management lets us do report by exception, bidirectional command and control, and very importantly, in a lot of factory and manufacturing, is that if that network goes down, we can do store and forward, so that when our MQTT session comes back, we can slowly publish out the historical data, not creating a data storm, and backfill that trend data that's very important for OEE and MES type of applications. Now, if we take this a step further, remember, this is all about tools on platforms. We don't want to be coding on operating systems. We want tools that allow us to be able to quickly configure this. And if we look at this, I'm going to escape out here. If we look at this, we have all of this operational data on the right. We've got this brownfield equipment. We've got Ignition that gives us OPC UA server client, Allen Bradley, Modbus, Siemens, the EFM protocols. So now we have the tags in Ignition. We can start using the tools, and one of the tools is the ability to define a user data type, a UDT. Well, if we look at this from a modeling standpoint, that literally is a model. So when we define a UDT, we've defined a model. Now, instantiations of that become assets, and those assets contain measurements. And we know those as tags or process variables in Ignition. So now we've got the ability at the edge to be able to not only get the process variables, the information from our brownfield equipment, but put it into a model that all data consumers downstream can utilize. So now we'll start going into some of the features that I wanted to point out. Again, this was a webinar to kind of say, well, you know, we've done several webinars on MQTT and Ignition. We've done several on the cloud connectivity, but let's start taking a look at how we solve the problem, like Chris said, is in this example we're going to show you. So one of the things that I want to point out is that with Ignition, kind of the genesis of the ability to publish an atomic set of data or a record came from the fact that the oil and gas industry, excuse me, get a drink here. The oil and gas industry wanted to be able to take alarms, events, history, and configuration from flow computers out in the field. And from an auditing and regulatory standpoint, they needed to guarantee that that data was atomic. So really, if you think about SCADA, we never had the notion of a data type that was a data set, if you will. So we created the ability to publish records so that we could take alarms from flow computers, publish those as records, have those flow through the system, and then using our MQTT recorder module, literally insert those in real time into the SQL historian. Well, then we are able to do that with our export module to take it into regulatory bodies like FlowCal. But we expanded that in the capability of being able to create your own. So now with MQTT Transmission, you literally can go in and create a folder in your Ignition hierarchy. And here I've got an example. It says my atomic record, and I've got a pressure, an RPM, and a temperature. And I want those, when something happens in the field, I want to be able to capture those and literally insert those into an SQL database. So with Transmission, you can configure that to point at a folder. It provides you the published Boolean that when that becomes active, it publishes that entire folder structure and inserts it into an SQL database. Now, the next thing I want to point out is that we've had a lot of customers ask us about the ability to publish files. So in the field, we were starting to see the ability for end equipment to have a file that report a CSV file, and what we're going to show in this example, maybe an image from a camera, and be able to publish that file automatically. So what we've added in Ignition 8 is the ability to configure Transmission to look in a folder and take any file that appears there, publish that to MQTT Engine. Then MQTT Engine will take that file and we can chunk it up into small pieces if we're on like a cellular network, and then be able to put that into the host operating system file structure that Ignition is running on. And so with this, we can look at the example of that is that we could have PLCs, flow computers, DCSs, factory equipment, providing files into the native operating system that Ignition's running on, and then the ability to take and publish that. Then Engine receives that file, and then it puts it into the target directory that we've configured, appending, if we want to, optionally, the group, the node, and device, and be able to put that into the file structure in the native operating system. So we'll see how that plays into the solution as well. Then a few other features is that now with Ignition 8, we've got the ability to add custom properties to tags. So a lot of customers from a asset framework standpoint would like to add things like asset ID. So if I've got a 4 to 20 milliamp loop providing me a pressure, maybe I want to put the serial number or the asset ID on that tag so that as those properties flow up through data consumers, we have that information captured. So that could almost eliminate having to have other asset management in that we can combine that information. We've now got the ability to do property filtering, so we can optimize our birth messages by going in and either enabling or disabling tag properties that may be on our tags in our Ignition infrastructure. Uniquely with Ignition 8, we've got a new product called Sitewise Engine that lets us provide another tag provider that can consume models, assets, and tags from AWS Sitewise. Now, I don't know about everyone on this webinar, but I have a problem with remembering, okay, where does this TLS certificate go and what all the certificates that I need. So with Ignition 8, we've made it much, much easier to consume all of the TLS certificates required for our secure connections for MQTT. And we've followed along with Ignition in the expanded data type support. So we've added arrays, documents, and other data types that we support natively. And for a complete list of these, we've got those on our documentation website. So with that in play, with all those new features and capabilities, I'm going to turn it over to Ben to kind of go through what Opto 22 are doing with this technology. So Ben, I'm going to make you presenter and take it away.
Thanks, Arlen. I appreciate it. I've lost the screen here, but I think I'm coming through okay.
Yeah, well, you can see you're on video right now.
Yeah, no problem. We're coming to you live here from our Opto 22 facility where we manufacture the hardware that runs the software that Arlen was talking about. So I just want to take a minute to talk about that and show you what that entails. So by far and away, our flagship product is the Groov Epic, and Epic stands for Edge Programmable Industrial Controller. And real-time control engine, you can see nice touchscreen on there, color touchscreen, lots of interfacing ports, and plenty of modules, IO modules that we can rack up on the Epic. But what we really want to focus on today is the Groov Rio IO for the IIoT. And the Rio is an incredible module, as you'll see. There's over 200,000 IO configurations from this one module. Just really remarkable. It is intelligent remote Ethernet IO. It doesn't have a real-time control engine, but it handles IO incredibly well with multi-signal, multi-function. One of the really interesting things about this module is it's PoE powered. So if you look at the diagram there, you can see the red Ethernet coming in. That bottom port is our PoE port. So we can power this module and provide network just from that one Ethernet jack. The port above it, it's a 2-port switch. So it's perfect for daisy chaining and stringing Rios together as needed. And the nice thing about the Rio is that it has a native MQTT and Sparkplug-B client built in for the IO. So you can get up and running with nothing extra needed there. But from next year, you're going to be able to buy a Groov Rio version with Ignition Edge built in. So you'll be able to use all of the Cirrus Link modules in the Rio, which is going to be quite remarkable. Let's just talk briefly about how the software comes together to configure the IO. There's a web server built into Rio, and so you can call it up on your phone, on your tablet, on your PC, and hit the IP address, log in, and start configuring your 8 channels of those mixed IO signals. So if you want to, for example, temperature, well, we've got a variety of thermocouples, we've got thermistors and ICTD support. We've got 0 to 20 milliamp input and output, and we've got 0 to 10 volt DC input and output. We've also got discrete inputs and outputs, and some of the channels have high-speed counting, for example, frequency and things like that. We've also got self-wetting inputs for dry contact, and we can support up to 7 channels of dry switch contact, and that power for the dry switch contact, the self-wetting, comes from the PoE. So it makes for a really clean installation. We've also got 2 electromechanical relays there that can switch up to 5 amps at 300 volts. So great for really switching some pretty heavy loads there straight out of the Rio. Put all this together, and I know I keep dwelling on it, but 200,000 combinations of IO. So this one module, you're wondering, oh, can I put this at a well? Can I put this in a pump station? Can I? Most likely, yes, we're going to be able to adapt the signal count that you need. So how does this fit into your application? Well, we've got the IT at the top and the OT at the bottom, and of course Rio or Epic right in the middle, bridging the two together. So you can see how we can talk to different control and IO networks. In fact, we've got a lot of customers now already using the USB port on the Rio with a serial adapter, and they're able to bring in a lot of serial data from the OT into Rio, into the software. They can bring, of course, all their analog and digital inputs in, and then using Ignition Edge and the Cirrus Link modules, we can push all of that data up into the IT network, and it can be consumed there, as Arlen said, in lots of different ways that data can be consumed. So what's the difference between Epic and Rio? Because with the addition of Ignition, we're sort of closing the gap a little bit. So both are definitely industrially hardened IO, and both have built-in MQTT, Sparkplug-B, and Node-RED. Both products have firewalls and VPN clients for remote access and maintenance, which is really powerful, really handy. Both run Ignition Edge, and the Epic has the option to run full Ignition, and of course all the drivers and modules that Arlen has been talking about. The real difference is with Epic, we have a real-time control engine with a HMI built in. So that HMI can come up on the touch screen on the front of the Epic, or it's also got a HDMI port for running an external monitor. So you can panel mount a hardened monitor and just run a USB lead for the touch, HDMI for the video, and you can be up and running that way. We talked briefly about the 2-port switch on Rio. Epic's a little bit different. Its 2 Ethernet ports are completely independent, and that means they're non-routable. One for, say, your IT network and one for your OT network. You can segment those 2 networks through the Epic very powerfully. Let's take a look at our demo now, and this is how we've drawn it out so that you can get a good feel for what we're going to be, what Arlen and others are going to be showing you here shortly. Customer 1 down in the lower left in Bakersfield has a camera looking at a workshop through a modem there, and they have a Rio. Customer 2 in the middle, that's me here in Temecula. We've got our PoE camera looking at a SATEC and also a Rio through a modem. And customer 3, a little bit of Arlen's setup there in Kansas City. The important thing is that all of these locations are pushing their data, they're publishing their data to that central MQTT broker that Arlen's got running up in AWS. So they're publishing and subscribing, and you'll see Arlen utilize that bidirectional capability of MQTT to actually control hardware at my location here, this customer 2 location. But he doesn't know what the IP address is of that cradle point or anything like that. He doesn't need to. There's no open ports. All the data just gets completely pushed up. So let's just take a look at what the demo consists of here. So you can see my IP camera here looking at the SATEC meter, and we've got the cradle point modem and the Rio. Over to the side, we've got some extra demo gear set up. We've got a HDMI monitor with an Epic and Siemens and Allen Bradley there. That's a demo for another day. So we're primarily going to be looking at this collection of hardware here. So that's our customer 2 site. And how's it all configured? Well, here's where we start to pull it together. So I'm here in the Ignition gateway that's running on Rio. So you can see my host name up the top there in the browser, Rio Ignition 8. And this is the broker configuration. So this is all I need to do to set up to publish the data from the Rio up to the broker. And then I don't need to know who's going to subscribe to it from there on. And the important thing here, as Arlen has pointed out, I'm using SSL. So all the certificates are taken care of, all the encryption. This is a secure connection to Arlen's broker, and you can see that I'm connected up there. So the Rio is doing all the heavy lifting, pushing all of that data up to the broker, whether it's IO data, whether it's Modbus TCP data, any connection like that. The Rio is moving it all seamlessly up to the broker. So we'll just quickly call up the tag browser because I'm guessing we've got a lot of Ignition users on the show today, and I wanted to give you a good look at what the designer view looks like of where our tags are. So this is the designer from Ignition running on the Rio, and we can see that the SATEC here. We've got our frequency, hertz, raw counts, and engineering counts. Same with the voltage. And here's the file transfer that Arlen is going to be showing. So Arlen, let's hand control back to you, and you can actually show everyone with it through the demo there.
All right, thanks, Ben. Appreciate it. That's great. So I'm going to go to jump over your slides here. And let's go to the solution. So we had a customer that came to us and said, this is based on a current client solution that they will remain anonymous at this point in time. But this customer had thousands of pump jacks with pump off controllers already installed on them. So here we have this equipment out in the field that could provide us very valuable data, yet they were leaving 95% of the data stranded in the field. So this project was saying, how can we get the information that the controller, that pump off controller, was already generating, but it was leaving stranded in the field? So the business needs to really optimize a pump off or a pump jack there's this thing called a pump and a surface card. And that just tells us how well the well is performing on a stroke by stroke basis. So it'd be very valuable if we could get all of the information from every stroke, from every well. And right now, they were only getting a couple of cards per day when they could, they wanted a card per stroke. And they wanted the ability to provide additional sensor data because there were chemical tanks out there, pressures, pump states that were left stranded in the field currently. And the benefits that this customer could see was optimize the manpower, increase productivity, definitely reduce equipment failure, because if I'm looking at that well or that pump off controller in real time, then I can take immediate action if something goes wrong in the field. And I can optimize my chemical injection for all those chemical tanks that are out there where you have to inject chemicals into the well bore as you're pumping it out. So the overall expectation here is to get an ROI on this project in less than 12 months. So I'm going to go back to Ben's diagram. It kind of annotated a bit, is that using the Rio as the edge of network gateway and the protocols that are already built into Ignition Edge, we're able to pull this Lufkin pump off controller in real time at the edge. We couldn't afford to do that over the network, over thousands of wells, but if we move the polling out to the edge, then we can bring in all of this information. Now, again, as Ben said, the Rio gives us the flexibility for any future IO that may pop up, because as everyone knows, the good thing is you know what you know, you don't know what you don't know. And with the flexible IO and the Rio, we're able to cater for that. Now, the other thing we're doing is that those pump card and surface cards have over 400 data points. So we need to be able to efficiently collect that data, put it into a record. Remember, we need to keep these pump cards separate. So we have one stroke and we have a record that we want to publish, and we want that to land in the SQL database back at the Ignition Gateway. Now, the other thing they wanted to do was to be able to monitor this site, look at the well, look at the pump off controller, look at the chemical tank, using a PoE camera. Well, that became a perfect utilization for the new capability to publish files over MQTT Sparkplug. So now we could capture a JPEG image from those remote sites on a timely basis and be able to publish those back into and visualize them on our Ignition Gateway. And lastly, we're doing all of this over a cellular network. So we're taking advantage of the efficient information delivery, i.e. reducing the bandwidth that would have been required by 80 to 95%. So if we jump into our actual demo here, the first thing we're going to look at is the ability to go here, and let's go to our pump off controller, is the ability to do our transmission records. Now, remember I told you that we've got the ability to take a folder in Ignition and publish that as an atomic record. So what we're doing here is we're doing on-demand polling in Modbus and picking up all of the surface cards and the pump cards required, along with some of the information. So for this stroke, here's the maximum load, the number of points that we had for that, stroke length, timestamp, and the well ID. Now with Ignition now, we're able to build that into a folder. So we have our pump card and we have our surface card. So think of these as atomic sets of data that we want to inject directly into our SQL database. So what I'm going to bring up is a view of our SQL database. So here I've got SQL Pro, and it's looking at my SQL that I've got installed here. And you look over here, and here's the current tables. Now with MQTT Engine, it will automatically, when I publish a record, is going to create a table. So I'm going to go into this Ignition Edge, and I'm going to say, okay, I've got a stroke. I want to publish all the cards right now. So that went from Kansas City up to the cloud, hit the broker, engine saw that message. And now if we go and refresh our SQL database, notice that we have a new surface card table that's been created. And notice that the name, I'm incorporating the well ID in that name, so it creates a very unique table with all of the information that I need. Now, Avadine are going to show you that now they can read this entry in the SQL database and start creating visualizations based on that information. Now, as Ben said, the other thing that we have is that we've got Opto 22 in Temecula publishing information. So I'm going to go to Ben's demo that he showed you in that demo, and he had a backlight on his Rio. And we're going to go up here and remember that he added the ability to publish a file. And so he is watching that camera capturing JPEG images. And then up here, customer one in Bakersfield also has a camera mounted on his Rio as well. So what I did was, with the new perspective module, is that we're able to create a view of these images that are being published. Now, just for all the Ignition users on here, I'm going to just show you very quickly that the new web dev module lets you create a hook into your operating system that you're running on. And so my folder path is actually looking at where Engine is placing files that are coming in from cameras or whatever files are coming in. So I'm able to look at that through web dev and create a view of that. So right now you can see that the backlight for the Rio is turned off. And so I'm going to go back into my tags, and I'm going to go into that Epic, and I'm going to turn that backlight off remotely. So we'll go into here, modules, panel light. And right now the value is 0, and I'm going to change that to a value of 10, which is going to cause that backlight to come on. And then I'm going to go up and I'm going to request an image be published. So remember, we've got the ability to do automatic file transfer or manual. So if I click on this button, that's going to say, go grab that image and publish it again. So that's publishing in chunks or over a cellular network. And boom, now I've got a new image. It just showed up and my backlight is now on. So if we look at what our solution was overall, is that we wanted to be able to get a card per stroke from the pump off controller and publish that as an atomic data set into an SQL database. And then we wanted to be able to take images on demand so that we could look at the chemical tank, we could look at the pump off controller and be able to publish those, provide those to Ignition. And then as you can imagine, you know, what else you could do with that using scripting and Engine. You could move it to S3 buckets for long-term storage or whatever you wanted to do. But now the interesting thing here is we've got all that information in the SQL database and in Ignition. So now we would like to visualize that. So that's what Avadine are, and Kyle will do the introduction, but Avadine have created an MQTT an Ignition dashboard that lets us utilize all this information that we're bringing in efficiently. So with that, Kyle, I'm going to make you presenter and take it from there.
Awesome. Thank you so much. Let me go ahead and get the screen set up.
Okay.
There we go. So you guys should see the demo now.
Yep.
So as Arlen was saying, we've taken and made an HMI in order to demonstrate and show some of the data. Real quick introduction to myself, I guess. Sorry. My name is Kyle. I'm project manager with Avadine, like we said at the beginning. We're gold integrators, and we've done some pretty innovative solutions for our customers that have some difficult problems. But like I said just a little bit earlier, that we're going to be demoing this mainly for pump-off controllers is the main usage that we have. It's tailored to oil and gas. But you can also think of this as being available to implement in a variety of environments. In other fields, just imagine you have data coming in from PLCs, SQL databases, or if you, like Arlen was talking about, the great capability of doing a single source of truth through MQTT. We can take your data and visualize it in any way that you like. In this demo, we developed a solution for those POCs, and one of the great powers of this group status table that I'm going to show you is that it allows you to have and show data in real time as it's coming in from your devices or from your main source. So each individual column is going to be an attribute about that well that is coming through. And what I said about being customizable is that this view that I've built here is actually something you can build on your own. So if you wanted to know, like this one right here is just a test. It's showing the well name, whether it's running or not, if the idle time, strokes, and then the pump depth and percent runtime. So if we wanted to create a view specifically for a customer, or let's say I'm a customer coming in and I want to look at some different information. Someone else has already built a view, but I want to look at something different. So you would go into your well configuration, your view configuration, and then you would add, let's say you wanted to have alarms, idle time, oil production. You want to know if it's running, how long it's been running, the percent fill, and the well ID and well name. You would go ahead and just add that all in. It would then automatically populate into the right over there, where you would be able to either select a current view that you could edit, or if you haven't selected one, you can go ahead and create a view. So I've already created one for myself down here. And so this one is going to be just basically how long this well has been in service, the well name, running, and you have the water cut, any production, and you can automatically customize and move any of the table information, and you can save these this profile to a particular user, which you could have it be private, or you could have it public, so that if you have a particular group status page that you want everyone to monitor, you could create that particular profile so that it's viewable from everybody, viewable with everyone. So just wanted to touch on how awesome the configuration there is in customization, kind of a brew your own solution there. So the second part that I wanted to demonstrate was what Arlen was talking about earlier with the pump-off controller dynacards and being able to show that information. Now, I'm going to go ahead and retrieve the card lists. So these are the different dynacards that are in the database. From MQTT, gets pushed into the SQL database with those XY ordered pairs. And then we can just visualize that by clicking on the individual card. It will then push that information onto the chart with the ordered pairs. And as you can see, it pushes the information on the chart. Just some background information: the more square the service card is, the better, the more efficient, basically the closer to normal that operation is. So if you wanted to see a downhole card, you could also add that as well. And it would just overlay onto the same chart. And so let's say we wanted to do some comparisons. We wanted to really analyze and see if something's going on. And just like going back again, I keep referencing to Arlen, but he made some awesome points, is that we want to be able to utilize this data coming in more frequently to be able to reduce your equipment failure, be able to reduce manpower, and then improve efficiencies. So just imagine that you're getting this in every stroke, and you notice that all of a sudden you get a card that looks like this, and you're kind of wondering what's going on. Well, this might be indicative that you have some gas, some extra gas in that particular in that pump jack, and you might be reducing efficiency, putting an extra strain on the equipment, or other things of the like there. So this would be a really quick indicator, something you'd be able to see right away. Hey, I need to go have someone take a look at this, or take the appropriate action, depending on what you see represented. So the and that's kind of what we have there. And if you imagine multiple environments, you could think of being able to display whether it's a pump, whether it's a valve, whether it's a tank, any tank information, you would be able to display anything overlaid over multiple instances, like time slices, to be able to view and get that information. And then with that, I'm pretty much done with the demonstration there. We also all have some time historical data as well as a historian, but that's mainly utilizing Ignition's time historian. So I'm going to go ahead and push this back to you, Arlen, if you're ready for it.
Thank you, Kyle. That's great. Again, Avadine has done some fantastic work with being able to work with this customer to provide the visualization that they need, and it's all with the tools and everything with Ignition. So with that, with the time that we've got left, just a few minutes, here's the links to Cirrus Link, Opto22, and Avadine. And Chris, I'll hand it back to you, see if any questions came in as we wrap it up.
Very good. Great job. Thank you very much, Ben, Arlen, and Kyle. Great presentations there. Yeah, we had some really good questions come in. Just before I start that, though, to point out, in the control panel of the webinar, there are some handouts, one from each of the companies with some useful information. So if you want to download those handouts, now would be a good time to get them. So a few questions, one for you, Arlen, here. What other industry applications could use records?
Well, you know, it's interesting. As I pointed out, we designed it for the electronic flow measurement, but we found out that once cut, and that's why I wanted to bring it out in this webinar. It was kind of like that little hidden nugget. We have in manufacturing, in solar monitoring. We're seeing a lot of customers, the IT department says, you know, we want to get this piece of information or these pieces of information, and they're using the records capability to say, okay, that's great. We'll take these process variables, we'll put them into a Ignition folder, we'll publish those, they'll show up in the SQL database, and go get it. So we're seeing it across multiple vertical or horizontal industries, definitely.
Cool. Good. This one I think is for you, Ben. What about the approvals and compliance ratings on the Groov Rio?
Yeah, great question, because we've got a lot of this stuff out in some pretty harsh environments, and it's obviously important. So temperature is minus 20 C to plus 70 C, minus 20 C to plus 70 C. And we've got the whole suite of agency approvals. We've got UL, Class 1 Div 2, CE, ATEX, and a few others there. So there's a nice Groov Rio data sheet available on our website. So just hit up opto22.com and you can pull that down.
Very good. Thank you very much. So we are at the top of the hour now. So one last question very quickly that's just come in. Arlen, can we transfer UDT definitions with Sparkplug-B?
Yes. So we are publishing UDTs. So that's one of the powerful aspects of this. You can publish flat tags, which means they're just published as tags, if you will. But if you define a model at the edge or at a factory location, once you define that model, it can be published to Ignition. And also in our previous webinar, we showed how that can also be published into AWS Sitewise service as well.
Excellent. Well, that's the top of the hour, so I'll be conscious of everybody's time. Thank you all very much for attending our webinar today, and we hope you found this useful. The whole webinar has been recorded and will be posted on our website. If you need to review any of it or pass it on to anybody else in your organization, that'll be available for you later there today. Thank you very much.